again. It is from the desk of Lady Ada. We're here at my desk. I'm Lady Ada. Thus, we are ready to rock. Also, Mr. Lady Ada is on camera control. Thank you so much for taking care of the camera control and making sure my microphone batteries are charged up. It's going to be awesome. Tonight, I'm going to spend maybe 15, 20 minutes. And I'm going to be working on, this is actually a larger scale project I'm working on called Circuit Playground. Well, that's the code name at least. But tonight I'm going to be basically creating a package for this SMT buzzer. I'm also going to be testing out this SMT buzzer sample. I want to basically have the circuit board be able to make noise. And to do that, I need to have a piezo or a buzzer. Piezos are a little easier to work with, but they're through hole. Like they're ceramic, and so you have to have wires. And I really want to avoid any hand soldering for this circuit board, so I'm going to be using this surface mount buzzer, and it's a magnetic buzzer, so it's actually kind of like a little bit of a speaker. I got the data sheet pulled up. I'm going to do some soldering, some EagleCAD, and maybe a little bit of Arduino code. So let's get this party rolling. Open my samples first. And then these are my little bag of samples. So let's go to the overhead plus screen. Thank you. Okay, so this is one of the buzzers. This is, well, there it went. Don't look at the camera while handling the samples. So I always get 10 samples of everything.
I think when I do my AV card, I'm probably going to have it so you can see this. I think it's helpful for you to see it.
Yeah, well, we'll have like a thing. I can also have my screen or whatever.
Yeah.
That's cool. We have the technology. We have those quality displays. Look that up. Okay, so this is my buzzer sample. And let's see if I can get it to more focus. There you go. So yeah, it's got a little marking here. That is the plus symbol, which tells you which one is the positive pin. And then here, there's a little port. So it's like solid plastic with pads on the bottom, but there's a little hole, and that's the port. So inside, it's actually just like a coil. It's actually like a teeny little speaker. I don't know, maybe I should pop one of these open and just see what it looks like. My screwdriver. Screwdriver option. I've never actually opened up one of these buzzers. Let's see what's inside. Huh, interesting. So yeah, there's this little diaphragm with it's like a magnet. I don't know how I'm gonna pry this off. Oh, hold on, this is not actually solid metal, this is just a little piece of foil. Get at everything else. Okay, well that just came off. This little magnet. Okay, so I got this open. So yeah, inside you can see this little gold thing. So that's just a coil wound on a little magnet, and then there's this little foil piece, and then there's another magnet. And yeah, it's actually just like a teeny little speaker. That's kind of cool. So yeah, this is just the diaphragm for the speaker, and then there's a magnet, and then the diaphragm just vibrates to create noise. So it's actually interesting. It's called a buzzer, but it's actually just a little speaker more than a buzzer, and it's definitely not a piezo, which acts by the piezoelectric principle. This is like electromagnetic principles. So this is more Maxwell's equation kind of action going on here, where you're just creating a magnetic, varying the electric current to create a magnetic field. Okay, so that's good. Destroyed that one. Let's grab another sample. Don't forget, always get 10 samples. And for this one, I'm going to solder some wires to this. I'm going to get some wire. action here. And then, let's see. Cut 2 pieces. I don't need them to be too long. And then I'll do a crummy job of stripping them. Good enough for prototyping. Okay. And then I've got my soldering iron. Okay. Tin 1, tin the second. And then look again. So yeah, there's the positive wire and the negative wire over here. So soldered these 2 wires. And it looks like there's just a couple other pads just for mechanical strength, maybe, I don't know. Okay, 1 wire. And then the other. Okay. Actually, I should probably look at the data sheet to make sure that that's how it goes. Let me see. Oh, data sheet doesn't actually have a pinout. Well, oh wait, it does. Polarity, yes, it's these 2. These are positive and negative. Okay. And then we can check that we did it right with our multimeter. So it's going to be very low impedance. Flip around a little easier to read. Okay. Yeah. So 16 ohms. Yeah, that makes sense. It's 16 ohm speaker. That's about what the data sheet says anyways. So that's good, got the pinout right. So put that aside. Just check the camera. Okay, so I'd like to actually, I'm going to be driving this basically with an Arduino compatible. So I'm going to try just kind of hooking it up here to, I got my Metro Mini. So look at the data sheet. It actually suggests to wire this up in a kind of a Class A sort of style, or driver style. No, oh, you did. Hello. Okay, so yeah, this is the pinout polarity, so it's the data sheet. And it says, drive it with like 2 to 5 volts, but 3 volts great. 16 ohms, that's what we measured, so that's good. And it says, okay, do this thing, which is, it's magnetic, so you have to have a flyback diode to protect your power supply. But basically, put in your audio and just make sure that, this is just your base resistor to make sure that you're not driving a huge voltage directly into the base, because the base can't be above 0.7 volts. So this is just kind of like, you can figure out like what the base current is. It's kind of a cheap way to bias. I mean, it doesn't matter because it's a square wave, whatever. And then it basically just like square waves the buzzer. I mean, the thing is, you could actually probably get, I mean, not great audio, but you could probably kind of sort of PWM audio and make it sound like something. But we'll just try tones to start. So let's get the things we need. So we need NPN transistor. Transistor. Some light so I can see what I got here. PN2222. Those are pretty good. But I like my 2N3904. 3904 the NPN? I can't remember. 2N3904. Can't remember which one's the NPN, which is the PNP. NPN. Okay, great. So 3904. Sweet. So add that. Okay, next up we want a diode, and we can go with the signal diode. That's fine. The reason you're like, well, wait a minute, but you probably want a power diode. Well, not at 16 ohms. Like, we're not talking about a lot of current here. These can do 200 milliamps. That's plenty. So, okay, let's wire it up. So, emitter-based capacitor, emitter-based collector. So, put that transistor there. Okay, let's get some wires. Let's do the emitter to ground. And then the collector goes to the negative of the speaker. And then positive speaker. Huh? Yeah, go on. Later. I'll figure stuff out. Positive goes to 5 volts. Power of 5 volts. And then for that, we need to have that protection diode. So, you want the line, which is the cathode, to go to VCC. So we'll just tuck this over one, and then pop this right in. Bam. Okay. All right. So next up, we would like to have that signal line. So we'll put in a wire here to represent our signal line. And we need some sort of just resistor. And it actually doesn't really matter what value it is. But it can't be 1 mega ohm. So I'm gonna go check out my diodes or my resistors. Got my box of resistors. 22 ohms fine. Go with that. Or 220. 220 ohms. Okay, so that's my base. Okay. Now, if I want to be smart, I would actually calculate out exactly what base resistance I want. So I'm actually going to have a 3.3 volt peak to peak, and that's going to go into this R base. And then, let's just say this is also 3 volt, because my final system is going to be 3 volt. And this is basically 16 ohms because, it's inductive, but whatever. We're going to basically just call it by the DC current, by the DC impedance. So, we're going to saturate this all the way. So this is going to be, this is the base, and this is the emitter. VBE is going to be 0.7 volts. Maybe a little bit higher, whatever. Basically, 0.7 volts. So the voltage across RB is going to be 3.3 minus 0.7, right? Because it's 3 volt peak to peak. Minus the 0.7 drop here. This is 0.7 volts divided by RBE, and that's going to be the base current. And the current that's going to go through here, ICE, ICE is going to be, it's beta times IB, which is basically 100. It's actually not, but it's a pretty good approximation. And we know that this current is going to be 3.3 volts divided by 16. So this is max 200 milliamps. But maybe we want to actually control that, right? Like if you want to have like, say the max is 100 milliamps or whatever, you'd actually want to adjust RB to change it. I'm okay with the max. So the max is 200, which means that IB is approximately 2 milliamps. Okay, so I can now solve for this. 3.3 minus 0.7, which is 2.6, divided by 2 milliamps is RB equals 1.3K. So as long as you keep it around like 1.3K, you know, it's just kind of like nice if you're going to do this. You don't end up driving the transistor too hard. It's nicer on the output of whatever's driving the square wave, because you are current limiting it to only 2 milliamps. So I picked 220 ohms. It's a little bit low. Maybe I'll go back and I'll dig out about a 1K. Here I got a 1.5K. See, biasing transistors is not that hard. I mean, you missed it.
Make it look easy.
Because you were going downstairs.
Yeah.
But the thing is, it's kind of like picking resistors for your LEDs. It's like, you could always pick whatever, but like, why not just pick the right value? You know, just do a little bit of math and you're ready to rock. Okay, so you got the 1.
I like that we're back to our roots with what we used to do in Ask an Engineer.
This is exactly what.
With drawing on a sticky.
Why haven't you gotten me the whiteboard yet?
Well, the whiteboard never worked. Like, this is just better. Like, you did. This is better.
Yeah.
I mean, I guess you can get an iPad Pro and a stylus and a pencil, but none of that is ever gonna work.
It's never gonna work as well as the
Yeah.
Oriental Logistics group. I got this pad from them like 5-6 years ago.
Yeah, you're halfway through it.
I'm kind of working my way through it. This actually was twice as big too. This was a brick. This was one of those ones that was like it was a square block,
Yeah.
and it came on a little adorable little pallet. Remember that? Like it broke, but it had a little wooden pallet that was made out of popsicle sticks. Anyways, it was great. So yeah, that's how you do stuff. Okay, so where were we? We were going to control the output with some analog, not analog because we don't have analog. You don't have a DAC on this, but we could control it with PWM. So let's do that. First, I'm going to put my samples away. We're kind of done soldering, so I'm going to turn off my iron. And let's go to this screen share for 5 minutes, and I'll just load up an Arduino sketch and just try this out. Okay, I'm loading Arduino. And there's actually a tone example. So if I can get this to start, I missed so much with the IDE that I'm not surprised it's not happy. Okay. Examples, I think there's a basic digital tone melody. There you go, circuit, 8 ohm speaker and digital pin 8. Great, so we're gonna connect this to digital pin 8. Okay. And let's pick the, this actually is going to be an Arduino Uno compatible. Get on with it. Port 12. And this is just tone. kind of glorious. That's how you know your sketch is completed. So I'll actually put the microphone next to the buzzer so you can hear it, and I'll reset the Arduino. So that's it. So we basically have a little amplifier. Doesn't sound too bad. You know, one of the things that we could do, and I'd have to research whether the chip I'm going to use has this, is if I've got high frequency PWM output, like the AT-Tiny85 does, which is pretty sweet, but I don't know if the chips I'm going to be using do. What you can do is have a PWM output and use that to drive the transistor. You can't do it with the simplified drive circuit that I've shown. You actually need to have a slightly more complicated biasing circuit, because if you want to have AC, like right now, just like it just goes up and down like really, really hard. Just like turn on the transistor, turn it off, turn it on, like, you know, at kilohertz speeds. If you want to have it have like analog output, you have to have a DC bias and then the small signal analog output on top of that. So, you know, we can do it, but it's a little bit more work. I don't think you need an op amp. I think you can do it with a couple of resistors and stuff. But you have to basically RC filter the output to get the PWM frequency out, and then pipe that into that transistor, which is an amplifier. And as a note, this is not a very efficient amplifier. It's a Class A, but it's super cheap. So my goal with Circuit Playground, the circuit board I'm designing, is to make it as cheap as possible. So I'm willing to give up a little bit of efficiency for the price of basically, you know, maybe 2 or 3 resistors, a capacitor, and an NPN. All of this costs less than 5 cents. And so that's my test. So far, so good. I didn't get to the EagleCAD, but I had fun messing around with his brother. Maybe it was a teaser. Maybe next time I do this, I'll EagleCAD up.
It's a 23-minute wrap it up.
Yeah, I think we should wrap it up. I'm at a good stopping point.
Okay. Good work. All right.
Try a new song.
Everybody was good, so bring a cat over.
Oh yeah. If all the people in the chat are polite,
Yeah.
we reward them.
He's an old cat, so when he dies, it's their fault. It's because they weren't good enough in the comments. That's
Jeez.
why. But if they're good, they can,
Heavy.
Yeah, they can see him.
Okay, you wanna pass
Yeah.
me the cat?
Yeah, here's it. This is well.
I got him. He's just a little spooked. He's like, I was sleeping.
Yeah.
Why did you wake me up? He's always sleeping now.
Yeah.
Okay, hold on. I can. Wait. Extract the claws. Wait, no. Okay. Well, first up, do people get to see the cat?
Yeah.
And then, what? Hey. Okay. He's dark, but he's here. Cat belly.
Okay.
Okay, and that's a cat,
That's it.
and that's a show. This was live from the desk of Ladyada.
Yeah, tomorrow 7:30 p.m. Eastern Time is show and tell, and then 8 p.m. Ask an Engineer.
Yeah. Okay. Bye. Bye.